Good afternoon. So this is tutorial number 2 in City Room 3. And this is being run by Jacob Taylor, and the name of the tutorial is It's Proxies All the Way Down. And I'm sure that's not a Terry Pratchett reference, honestly.
Either that or it's life imitating art once more. So this is a tutorial. Basically, we're going to be looking at Envoy Proxy and xDS and a few other things. There's a few different labs, 5 different labs in fact. We're just going to go through and a bunch of sections. This is sort of the general outline. There'll be room at the end for Q&A if you want to have a bit of bant, whatever. Of course, there will be pauses, obviously, during the lab time, at which point I'll come around to make sure everyone's doing okay, following along, and you're more than welcome to ask questions then. But without further ado, for those of you who are on time, what the hell is Envoy? The way they describe themselves online, Envoy is an open source edge and service proxy designed for cloud-native applications, which is an awful lot of words saying not much at all. It doesn't give you any idea of what it actually does, and there's kind of a reason for that. The sort of, history of Envoy was actually created at Lyft, but it has since sort of been the custodianship of the project, as it blew up, was transitioned from Lyft to the CNCF, basically the same organization that owns Kubernetes and an awful lot of other open source projects. So it's a big boy project. Few quick facts, I guess. Envoy can proxy and load balance all the things: TCP, UDP, HTTP, gRPC. gRPC is technically a subset of HTTP, but whatever. We'll consider it a separate thing. Envoy supports different options for extensibility with custom filters, sidecars, and yes, for when you're in a real pinch and you want to absolutely maximize the work not done and add some additional tech debt, there is scripting support as well. And finally, Envoy supports dynamic reconfiguration at runtime using xDS. What's xDS? Hold that thought, we'll get to that eventually. And this sort of, takes us to our first lesson. Basically, this is just get everything running. Clone this GitHub repository. You can go through the setup.md instructions, and then we'll then run through part 2. And just raise your hand once you get to the end of part 1 there. And I'll, or if you need help, just shout out and I'll come over and, although I would hope everyone here can at least do part 1 by themselves. everyone clone that all right? Yep. Okay, then just continue, I guess, the instructions. Do just start one and just go to localhost 8080 and you should hopefully see something. The first build will, as you can see, just take a while because it has to download some very chunky containers. But once we get those all cached on our local build context, it should be fine to go from there. Yeah. Oh, did that? Oh, probably. Yeah. Hello, Envoy. Is anyone up to this point yet, or? Yep. Yeah, there's a reason I decided to tether to my phone. But yeah. Anyway, it's pretty straightforward. What I'll do is I'll proceed through the next couple of slides. You can continue pulling containers, doing all that stuff, and that will happen in the background. Ooh, okay. Righto. Okay. So before we go into like the bits and pieces of Envoy, it's important, I guess, to get an idea of where it fits into the wider ecosystem of, all these other technologies which, seem to do the same thing or similar things. How does it differ? So, a very popular sort of long-term stable choice for like ingress proxying is Nginx, obviously. I remember like Nginx being the new hotness back when I was in university. But the thing, while Nginx over the years has basically just gained an incredible set of features, it kind of started its life as a traditional HTTP server, a competitor to Apache. And this, I guess, design assumption sort of permeates its interface, its configuration language, all of that. And all of the extra things don't really have, I guess, what you would call a sustainable, there is no standard way to increase or widen the configuration schema of Nginx. It's always a manual effort. Back in the day, Nginx, basically, it always required a process restart in order to reload its configuration. This has changed over time, but it now supports dynamic reloads, but configuration is still very much local to the machine. You still very much load your nginx.conf, blah, blah, blah. Nginx, a bit spicy take. Nginx is now owned by F5 Networks, a famously expensive vendor, who basically very much all of the new wonderful features that are being developed for Nginx are often gate-kept behind Nginx Plus subscriptions, and that kind of sucks, in my opinion. And Nginx has sort of, I guess, limited extensibility options. Not zero, but very often like third-party modules, a very famous example being like OpenResty, which basically added Lua scripting into Nginx. Basically just needs to be compiled in, loaded into memory, all that sort of thing, which you basically have to build your own distribution or use a pre-compiled community-owned distribution of Nginx with the particular extensions you have and want, or if there's no available, I guess, pre-compiled options for your particular set of extensions you want, you have to go and build it yourself, which is not a fun experience as a consumer. Envoy versus F5. As I said, F5 is very expensive. Basically, 83 cents per hour per node on AWS for one Envoy, for one F5 instance, versus Envoy, which is free. It's sort of, I guess you could call it an appliance-based solution with limited elasticity. The only unit by which you can scale it is adding an extra node and an extra 83 cents per hour to the money you won't be making. You can't like just run F5 as a thing in a container. Limited extension capabilities. I hope you really like writing iRules in TCL. Certainly takes me back to my Cisco days, but you know. And very, very complex opaque licensing for advanced features like iRules LX, which introduces sane languages to the programmability options there. SSL orchestrator, APM, there's so many different options there, and it's all very confusing, and probably if you don't hire an expert to manage your F5 licensing, you're probably doing something wrong. Envoy versus kubeproxy. If you work in Kubernetes and cloud-native environments, you would have heard of kubeproxy. Shock horror, kubeproxy is not actually a proxy. It does not terminate and then originate layer 4 sessions. If you've ever seen the F5 architecture documents, they will often talk highly of their full proxy architecture, and this is that's basically where you actively terminate a TCP, like you have one TCP session, then your proxy doing something, and then another TCP session, rather than manipulating an active TCP session. And basically, instead of doing it that way, it orchestrates the configuration of various OS level packet manipulator facilities, IP tables, NF tables, IPVS. The kubeproxy binary only really configures these elements, and it performs no data plane function in its own right. Kubeproxy only supports layer 4, basic, round-robin LB support, no application inspection, TLS termination, none of the cool features that we really want. It's very tightly integrated with Kubernetes, which doesn't really come as a surprise. It's in the name. And finally, Envoy versus Istio. Istio is a service mesh control plane. It's like kubeproxy. It does not actually forward traffic. It basically configures a certain other element to basically move traffic around Kubernetes clusters by configuring a certain proxy, and that proxy is Envoy, as it happens. So if you're ever wondering, oh, I've heard of Envoy, but I've also heard of Istio, that's the relationship between the two. Istio does support all of the advanced L4, L7 traffic management stuff. Basically, anything that Envoy can do, Istio can configure. Some features are exposed via higher order abstractions like Gateway API, and some require sort of basically putting raw Envoy configuration into a config map and hoping it works. And basically, one Istio control plane instance may manage multiple instances of Envoy. So that's how they relate. So we know where Envoy kind of sits in the grand scheme of things, but like, how do we configure it? Like, what makes it tick? So the thing you need to know about Envoy and its configuration, there are many different ways to configure Envoy. You can use JSON. You can use YAML. You can use CLI args. You can use xDS, which again, we'll get to in a bit. But at the end of the day, it's all the same thing. It's all mapped to a single protobuf construct within the Envoy process. And there are three major sort of core configuration elements within Envoy that you need to be aware of and the relationships between them. There are listeners, which basically bind a layer 4 socket, so a TCP listener, to a list of filters. Filters are then what actually implement the features that we all love, things like TLS, things like HTTP, things like HTTP routing. And then all of this kind of flows towards clusters. And clusters represent what you're proxying to. I personally don't like the nomenclature because not everything in the world is a cluster. I would have called it an upstream, but yeah, that's what I'm saying. Yeah, it doesn't actually have to be something highly available. It doesn't. It can just be, a web server running on localhost. In terms of taking a deeper look into filters, listeners can have network filters and listener filters. And basically, filters themselves may then be composed of subfilters. The HTTP Connection Manager, or HCM, is a listener filter, which then contains a list of HTTP filters. So the HTTP Connection Manager is a filter that contains subfilters. If you're a more of a visual person and just don't want to listen to me ramble on, this is kind of a visualization of these relationships and how you can have multiple listeners to, say, do something as simple like what we would consider sort of a default configuration within Nginx of like, hey, I've got a HTTP listener, I've got a HTTPS one, I want to redirect. And that's how you can kind of do it. And then you've got like your bunch of clusters that you have down the bottom that represent different things that Envoy can connect to. And another thing when it comes to clusters, not everything that is a cluster is something that you are necessarily forwarding clients to. It can be something that Envoy is connecting to perform some kind of task. But we'll talk more about those kind of things a bit later. Another very important concept within Envoy is what we call session context. Basically, each connection within Envoy receives basically an internal session identifier. As a connection sort of flows through this request pipeline that we configure, you can then, filters can then attach metadata to that session. And then these context values can be consumed by other filters that execute later on in the pipeline. So a very common feature that is utilized in Nginx is SNI, like being able to inspect the SNI record value within the TLS handshake and then choose a certificate that is appropriate. And like in Nginx and other things, how that happens is kind of skewed for me. You just sort of configure it and it happens, it's magic. But within Envoy, because Envoy is more like, I guess, a configurable stream manipulator, it's like the way that it's implemented is just an extension of its existing capabilities. So basically, you have sort of this early filter that goes and looks at the TLS stream, particularly at the handshake header, and says, oh, this person is trying to TLS. Oh, there's an SNI header here. Okay, I'm going to add this into that connection context. And then as you then move from the listener filter to the filter chain, it then says, oh, I've got like a bunch of matches here. And I'm going to match against the correct host name that is provided by the earlier filter. So that's how that particular, and then that contains the association to the TLS keys, and then all of the other configuration under that, such as the HTTP Connection Manager, routes, so on. I've said the words HTTP Connection Manager a few times at this point. It's probably the most important one if you're running HTTP gRPC services using Envoy, which is probably, I would say, 90% of Envoy's use case these days. Basically, the HTTP Connection Manager is a network filter that understands HTTP, funnily enough. It supports HTTP1, HTTP2, and HTTP3 as well. So it has its own special class of subfilters, as mentioned before, which are those HTTP filters. The HTTP filter list is basically, as I said, it's a list, and each request goes through them linearly. And at the end, there must be what is known as a terminal filter. And most commonly, in fact, I've never seen anyone not use this as a terminal filter. It's the HTTP router filter. And then the HTTP router allows you to express the intended behavior based on a series of rules. This is your classic, path matching, method matching, all of that sort of thing. And also, it doesn't just allow you to map to clusters, it allows you to map to certain other response types as well, such as like, oh, I just want to return a string to the client, which is exactly what happened in Lab 1 when it said hello Envoy. That was what's known as a direct response target, I guess you could call it. And yeah, it was just returning a response directly from Envoy itself. And yeah, and you can also add in additional manipulations there, like, oh, I want to fiddle with some headers. I want to add one on the request going to the cluster, or I want to add one to the client coming back. It's really up to you how you define that behavior. And that sort of, I guess, brings us to lesson 2. Did anyone have any trouble with the previous one? Yeah, you? Yeah. Okay, cool. You sure? Okay, cool. All right, so basically, similar to the other one, just do just start to, or follow the instructions in the setup guide if you did not install just. And basically then just go to that URL and sort of look at the logs. And then we're going to go and basically edit one of our little config files. That should say lesson2.yaml. I apologize. So edit lesson2.yaml. And then you'll find some commented outlines in there, and then run it again. And you'll see a difference there. So I will, okay, just cancel this out. So, unsurprisingly,
just start to.
yep, just start. Yep, just start to. When you go there, you see basically a readout of whatever headers have been provided from the client to the server. So we get our user agent. I'm a weird person who uses Safari, so it doesn't actually. Yep, there it is. And a bunch of other things. Also, you can see that Envoy's default behavior, it adds this expected request timeout header to inform upstream proxies of what its intended behavior are. Yeah. So, if we then go to our lesson2.yaml, and we'll see that there are these commented outlines here, which we can save, and we'll restart because we haven't. So I mentioned dynamic config earlier. Why doesn't this immediately restart? Because the config file is provided as a static configuration. So when we update it, we have to restart. We'll get to in a moment. Oh, hello. I'll be with you in a moment, just to get you up to where we're at. So that's saved. So no, yeah, we can. Oh, and I should have updated that to be 2. But anyway, so you can see by uncommenting those lines that, funnily enough, read. Request headers to add, we added a request header. Shocking, I know, but that just sort of demonstrates how you can manipulate requests using Envoy. Anyway, so if we go back over here. All right, cool. All right, so for the, I'll just, for the newcomer in the room, you can clone this repository up here, and yeah. This is, I've not tried. I did not validate it on a rootless Docker. I did try it on Colima, and that definitely worked. It's just between the. So I was using Colima on my, but then they mandated we have to use Docker Desktop, unfortunately. So yeah, I apologize. I should have been more thorough in my testing. Mm-hmm. You want me to come take a look? Okay. Yeah, I tried it on Linux, I tried it on Windows, and I tried it on Mac with Docker and Colima. That was the extent of my testing. I did not try it on FreeBSD or any other odd configuration. So, because there's so many different configurations, there's only so much I can do. But yeah, apologies. How are you going, newcomer?
I'm just planning.
Yeah, cool. Yeah, so when you get, once you're fully cloned, you can follow the instructions in the setup.md, and that'll pre-cache everything that you need and all that. So, but we'll continue. So now we're actually on to lesson 3, comes straight after lesson 2. So, funnily enough, just start 3. And this one is a little more involved. It requires you to use curl, very technical, I know. So if you have any trouble with this, do let me know. So yeah, we're going to we'll do part 1. So what I'm going to do is come over here to So yeah, once you get that third lesson running, basically run these curl commands. What it's doing is it's configuring curl to use a forwarding proxy to access. Sorry, my company really likes me touching my YubiKey every 15 seconds. So apologies if that pops up. Sorry? Yeah. Sorry, you good? Yeah. Okay. Yes. Then you know the pain of.
On the weekend doing some playing games.
Yeah.
Please log in. I'm like, I don't wanna.
But yeah, it's so when you do that, you will notice when you do use when you use the proxy to reach HTTP http://headers, you get an Envoy header injected into the response. But when you do it with HTTPS, you do not. Does anyone off the top of their head know why this is?
It's something to do with we're not doing
Yes. So when you use a, like a squid or something along those lines, and you proxy to an HTTP endpoint, you basically when you send the request to proxy server, you send basically what you intend to send the actual upstream server, and it does that. It replays that, and maybe does some manipulations on that as well, such as injecting headers. When you connect to a HTTPS endpoint, by default, what happens is that this is technically the user agent's behavior. What it will try to do is set up what's known as a connect tunnel. So the request that your proxy sees is what's known as a connect request, and connect is actually a HTTP verb, and basically sets up a TLS tunnel. So that's what allows you to use a proxy server to reach a HTTPS endpoint, rather than without basically being broken into in the middle there. So the clients can still fully say, yes, we're 100% secure. And you can actually see it here. So that first request in the logs, you can see host, header, yeah. And then in the host for the second request, and you can also see the method is connect, and the host has changed from httpbin.org to httpbin.org/:443, because you're basically, what a connect request is saying is, open me a tunnel to this endpoint on this port. And that's what's happening there. But that's a discussion for proxies, like forwarding proxies, which is just a bit of trivia at this point. It's not actually, for Envoy, it's all considered just I guess you could say, a different reconfiguration. It doesn't really care. Whereas you can't really configure Squid to behave like Nginx, and you can with the use of appropriate extensions that we talked about before, you can make Nginx behave like Squid, but it's a very clunky experience. Whereas with Envoy, it's just a rearranging all of the components. And we can visualize this by diving into our part 2. If you go to yamldiff.com and then just chuck in lesson 2 on one side and lesson 3 on another, you can see how, how similar and just how different the two configurations are. You're not really, and everything, if you look at what's been added and what's been removed, it kind of makes sense. Here's something I prepared earlier. I've gone and done this already. So you can see under static resources clusters, and we talked about clusters earlier, that's where we're sending things. Like before, we just had sort of this static cluster that basically, it's an address and a port value. Fair enough. And now we have something different, which is known as, it's actually a special kind of cluster called the dynamic forward proxy, which basically alters its upstream based on something in the request. And that something in the request is sniffed out by this additional HTTP filter down here that basically says, oh, this person is doing either a connect request or it's doing a non-connect request. I'm going to add this into the cache to and prepare for forwarding to the cluster. So basically, back here, it's sort of like sniffing the request and then doing a DNS lookup to pre-load the things before it hits the cluster, and then the cluster is ready to forward it when it gets there. So that's how that works. It's nothing special. It's also, we had to set some additional special configuration here to by default, for security reasons, Envoy does not allow connect verb to be used, which is fair enough. It shouldn't be used in most circumstances. And yeah, so that's basically it. From an Envoy perspective, that's how all those pieces fit together. So how do we go beyond? Yeah, exactly. How do we go even further beyond? Well, basically, Envoy by default, packs in a lot of functionality in the form of different filters and configuration options and all these different features that we really like. But what if your use case isn't served by the existing functionality? There are a few different options that we can, I guess, explore. And they sort of exist, I guess, on this spectrum in terms of both simplicity and flexibility. And they are inverse, as always. It's like, you know, pick two. In terms of the most complex, but also the most powerful and the most performant, we have custom C++ filters. You can go and write a C++ filter and build your own local distribution of Envoy, just like I talked about earlier with Nginx. I wouldn't recommend doing this as a first resort. Only do this if like you cannot find any other way to do what you want, and I suspect you will find something to do what you want. You can do it, and as a contributor to the Envoy codebase, it's a flaming dumpster fire in certain parts, but it's C++, so it's all a flaming dumpster. It's fine. You can do it. I believe in you. Then sort of, I guess in the middle, we have what I would call, this isn't a formal term, this is just kind of how I describe it, hosted language filters. Up there I've got the Lua and WebAssembly. They've recently come out with Golang as well, so you can, if you're really, I guess, masochistic, you can use Golang. Sorry, just throwing some shade. And no one really likes, basically all that really ends up being is you just add some C++ or some Lua code. You can literally just write some Lua code, include that in your YAML configuration, and it just starts executing on every request. It's not pretty, but it works. And like what I've seen at some organizations is it's often a first response option. Like for a very salient example from the not too distant past, the Log4j exploit a few years back. Basically, even though, we were running, I guess, a fleet of ingress proxies using Envoy, and even though we aren't the teams who were like responsible for patching the exploit because we didn't run things in Java, it was asked of us to respond, to be able to plug the hole at the source. And basically, our initial response was basically just to write a Lua script that would search for the particular signature and just drop the request as early in the pipeline as possible. And that worked. And like Lua, it's based on Lua JIT, so once it compiles, it's fine. But yes, it does get messy, and there are cleaner ways to do those things. And I guess at the far end of, I guess, what I would consider the most simple implementation options, but also the least flexible. And when I say least flexible, they aren't, you can do anything with them, but they're often, like, I guess, tied to very specific problem sets. And sort of the examples that I can quote immediately are XLC, which is external authorization, XProc, which is external processing, which is kind of like a catch-all, really, so you could technically do any kind of processing there that you want, and RLS, which is the global rate limiting service. And those are, I guess, tied to specific problems. Very common problems, like everyone wants to authorize a lot of requests when they're coming from the internet, funnily enough. And very often, when you configure these in your Envoy configuration, like you can choose how much information you want to pass to these extension interfaces. And like you could say, I only want to send the headers, I don't actually want to send the body, because that's obviously more efficient. And that choice is up to you. So we're going to take, I guess, a quick look at external authorization, which I guess you could say is the one I've seen the most, and also probably a good sample case. So basically, it's just a simple gRPC protocol. There's like one sort of method, and basically allows Envoy to, I guess, outsource authentication and authorization of requests to an external service. That could be simple as, oh, I'm going to look at the request source IP address and give a yes or no answer. That could be inspecting a JWT, doing some validation there, or some other aspect, some other piece of data that's in an authorization header. It could be something like you could inspect the whole request body and apply some sort of complex policy, like say evaluate an OPA policy. It's really up to you. It's whatever you can dream of and that you can execute within a reasonable time, you can do. The specifics of the process are generally very immaterial to Envoy. Only the result matters. It can be either an allow or a deny, funnily enough. It can also return, I guess, what you could call mutation instructions to Envoy, which like say, I want to inject a response header, or I want to inject a header to the upstream to tell it some information. You can also choose to inject metadata, which is what we talked about earlier, which is that basically context that is attached to the request as it travels through the Envoy pipeline. You could potentially have multiple of these filters execute and then have information pass from each one on the outcome of the decision. And so that brings us, I guess, to lesson 4. And we're just going to do just start 4, and then we're going to try again to access localhost 8080/headers. So in a regular browser, what this will happen is we try to, when we do this, we'll actually get a prompt show up. So what we're going to do is we're going to look at the source code and try to find what we need to put in there. Perhaps someone has found them already. Very secure username and password in the code. Give you a hint. You want to look at that file, and it's very obvious. Yay, fantastic. Yeah. For those who, it's basically up here in this like static map. Very secure credentials. But you'll notice when we take a look at the headers, we actually inject a a custom header there that just has the username that we use. And that's done by basically the thing saying, responding to Envoy and saying, okay, and also add this header. And if we take a close look at the sidecar code, it's Rust because that's cool these days. We can actually, so when we are constructing what we would call our authenticated response, we do some manipulation, blah, 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 and then we just like basically add a header to the HTTP response. The value client ID in this case is the username and some other bits and pieces. Because we're basically building like something akin to a protobuf response. There's like code generated constants and all that sort of thing that we have to kind of use to build the correct response. Another cool thing is that even if you're returning a negative like response from an external authorization server, you can still very much customize the response. So when we tried to access it initially, we got the little pop-up that said, give me some credentials, give me some credentials. By default, if you just return a negative response, that won't happen. You'll get like a 403 or a 402, something along those lines. The thing that makes a browser trigger that prompt, and this is sort of defined in the HTTP basic authorization specification. Yes, I did have to go and look up the RFC when trying to implement this. Is basically when if a server returns a 407, no, sorry, that's the proxy one. If it returns a 401, I believe, or a 402, one of them. It's actually probably be in here somewhere. Anyway, it will basically, if you also return a header called the w-authenticate and then a basic string with a realm, it will then basically challenge the user and retry the request. So if we go into a different browser, let's use Chrome. Taking its sweet time as always. So, yeah. Actually, what we'll do. curl-v. Yeah, so 401. So you have to return a 401, and then you return this header, and we have a realm. And like on some browsers, they don't really do it anymore because basic authentication is considered a bit gauche these days. That will like say that will be in the dialog somewhere. And if we again. Slash headers. So if you like pre-provide the authentication tokens, you don't get that sort of challenge and then response and like that. So you can either the user agent can pre-provide the credentials as part of the initial request, or it can try, fail, and then try again with the after you get that prompt. And you can also see here that is actually where the credentials are. Like that's that is basically you can literally see a repeated pattern there of it only differs because there's a little bit of padding, but that's base 64 for you. Yeah, so that's how you can use, I guess, a the external authorization interface to achieve arbitrary, I guess, request authorization that would not. And there are, like, say, built-in filters within Envoy that can be configured. Like, say, there's a JWT authorization one within Envoy, but if you have to do anything custom, like, for example, I had to recently implement support for Cloudflare Access, and while that uses JWTs, it doesn't do it in, I guess, a standards compliant way. So I had to go and manually write a sidecar that would actually handle that for us. So that was painful, but it was an awfully good learning experience. And you can see in the configuration for lesson 4, we have the HTTP bin cluster, which is the actual thing that we are proxying to. But there is also a external authorization cluster. And, like, people don't get proxied to this cluster. This is basically telling Envoy, hey, there's something here that you can use. And then we reference that down here in the HTTP filters. So we have 2 filters. We have the router that we talked about before, that's the terminal filter. But then up here we have the external authorization filter. And we basically just reference that cluster above here. Also of note is what kind of endpoint it is. You obviously would be familiar with using a host name and a port, but you may not be familiar with the concept of a Unix socket. A Unix socket is basically it's a file, because everything on Unix is a file. That's part of the founding philosophy, and basically it's when you connect to it, you can configure a daemon. Like, basically, you can configure, if you have MySQL and an app running on the same server, you can actually talk to MySQL using a Unix socket. From the perspective of this, like running proxies and that sort of thing, it's actually highly beneficial to use Unix sockets if your external authorization server and your proxy are co-located on the same host. And that can either be like you're just running them as like separate processes on a Linux host, but it can also be like, oh, you're running them on the same pod in a Kubernetes, and if you can like do an empty file mount between the 2 containers, even though they're separate containers, you can still use the Unix socket for communication. So that's, and I'll see if I can find it a bit later, but from, a $ previous employer, they actually like achieved significant benefit from changing from using TCP/IP on localhost to using a Unix socket, because, and they're not entirely sure why. The running theory is basically you don't have to like spin up a TCP session.
Is that just manning empty there in both? Like
So that's how you do it in Kubernetes. At previous employer, they just were running it. They were just using an auto scaling group, so it was just Envoy running and then the thing. But yeah. If you do want to do it on Kubernetes, be mindful. You still have to be very mindful of chmod rights. So you either have to make it available or ensure that your UIDs are in sync across your containers. Little gotcha. But with that, we can continue on. Where did my slide? There we go. So, dynamic configuration with xDS. So, we've got all these wonderful, nice features. But how does one dynamically configure Envoy? Funnily enough, using xDS, as has been alluded to multiple times in this session. XDS stands for X, Discovery Service. X is in algebra. It discovers something. What is the X in XDS? It can be one of many things. You can have listeners, in which case you use basically what you would call a what we call LDS, Listener Discovery Service. You can discover HTTP routes, which is Route Discovery Service. You can discover virtual hosts, which is, funnily enough, VHDS, Virtual Host Discovery Service. Clusters, Cluster Discovery Service, CDS. Secrets Discovery Service, and there's even more. You can do scoped routes, you can do load assignments, you can do runtime flags. You can discover like anything that you could. The XDS API is pretty generic, and if you were creating a new configuration entity within the Envoy tree, you could potentially create an XDS for it. And fun fact, as you may have figured out by this point, XDS servers are once again represented by Envoy clusters. But that then raises a very valid question. If XDS is used to discover clusters, how do you discover the cluster that you need to use in order to discover the XDS? Well, you basically do have this thing which is known as a bootstrap config, which within it you define statically a cluster which has which is your XDS control plane, and then from there you load your dynamic resources. So what is an XDS control plane? An XDS control plane is basically just a piece of software that speaks one or more of the XDS, we'll call them variants. It can be, there's a gRPC variant and there's a REST variant. Subscribing Envoy nodes provide their node ID and cluster name, which are basically, who cares, like they're just identifiers basically. And the control plane sort of just returns the resources that are associated with it. Where the control plane fetches the resources from is very much an implementation-specific detail. It could come from flat files. It could come from a MySQL database. It could come from, I don't know, a Kubernetes resource. Crazy. And control planes basically handle gathering user-intended configuration and then basically almost they're just a hyper-advanced templating engine. They take that information that is described and documented somewhere, that intent, and then build Envoy protobuf structures in order to make that happen, make it so. Sovereign is a control plane from the fine folks at Atlassian, and that is indeed previous employer. It's basically powered by Python, and it uses the Rext XDS variant. The XDS control plane that runs ingress proxies for all of Atlassian cloud products is powered by this piece of software. And that brings us to lesson 5, which is our, I guess, last lesson of this thing. I'll dive a bit deeper into this one, but after this, I'll open basically the floor up to any questions or whatever. And if anyone here wants to go back or verify something from one of the previous labs, we'll have time to do that as well. But yeah, if we go, so we're going to run just start 5, and then we want to navigate to localhost 18080. I really should choose different port numbers that aren't so easily mistakable, but anyway. And then we're going to navigate to the actual app, and then we're going to do some stuff, and then, yeah. But first, let's go to localhost, run just start 5, and then go to 18080 on localhost. So this is the Sovereign UI, and as I said before, Sovereign is the control plane that is written by Atlassian and runs basically all of their things. we can basically see we can inspect the resources that we are managing through through this. Okay. And so this is the actual Envoy config that is generated by the Python code that we're running. And if you compare this, let's just grab this and then head over to so you can see that basically this data is being used to generate this set of routes. So if we go to localhost 8080 on foo, we will get the string foo returned to us, funnily enough. So if we do this, localhost 8080 /foo, we get foo. But if we come over here and change this to not foo, and we wait a bit, it becomes not foo. And that's basically the sovereign control plane basically just polling that file, waiting, I think it uses iNotify or something along those lines to basically just update the configuration. And you can see in the logs that basically, because this is using the REST variant, it's basically just polling. Like Envoy is saying, do I have new config? Do I have new config? Do I have new config? Whereas in the gRPC variant, which is what we use at Canva for some of our internal services, it's streaming. So basically the server can say, oh, got new config for you. But I find this personally just easier to grok, particularly for people who are still learning. So that's kind of why I use this one rather than a more complex Go control plane that we use at Canva. But yeah, you can definitely come here and say, let's say, you have to add the service cluster's name, and basically what this does is say, saying, I want this route to be available on these clusters. This cluster refers to the cluster ID that I talked about before. It basically identifies a group of Envoy things that you want to behave the same. So there's a node ID that identifies the exact node. That might be, say, a host name or a pod name. And then there's a cluster ID that is common and shared across them all. And saying, what we're saying here is, yeah. 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 So, yeah, and that's basically, obviously this is a very simplistic example, but like you could write any code and that could take any sort of source of like consumer intent and basically use it as a template. Like you can literally see here, if we get rid of this sidebar, don't save. This is literally just a template. Template is Python code, but it doesn't have to be that. You can have, say, this. you can have, say, for example, multiple different types of clusters controlled from the single control plane, and like have like decision making based on like the node context as well as your data, your user data. It's really as creative as you want to be, you can be with this. And that's kind of it. But yeah. Yeah, let me see if I can. Where did my slides go again? Yeah. So, you know, if you're, I've got to have an obligatory, like, we're always looking for engineers slide here. Tris, you're excluded from this slide. Please. Sorry? Yeah. Oh, well, you're more than welcome. We need more people for the network gods. But yeah, like we're doing some really awesome stuff here, particularly in the network and infrastructure space. By all means, check us out. If you're really, really interested, I'm more than happy to like do referrals and all that sort of business. But yeah, we've got an awful lot of time. We've got a whole hour for me to answer questions and do all of that. So please, oh sorry, that's the next session. Sorry, we got afternoon tea until at 3:15, and then there's the next session at 3:45. But beyond that, I am more than happy to answer questions for the next 30 minutes, or yeah, or if you want to see something, I can give that a shot. It's up to you. Like any burning questions, thoughts? No? Yep.
Yeah, I think one of the plugins that sort of droppings you were talking about, can't remember the name of it, but I think,
Yeah.
yeah,
Remember that?
oh, maybe it wasn't that. I was thinking about doing like weighted balancing of requests between, say, you know, a newer deployment and an older deployment.
Yes, like blue-green, sort of, yeah.
Exactly.
100% doable. Basically, that would be done, like if Envoy is in front of your things, like so is Envoy the thing, like part of the deployment that you were targeting, or is it in front of, like, it is what's doing?
I think generally they're sidecars.
Yeah.
I think where we're using it most at the moment is actually for traffic between microservices.
Service mesh, sort of, yeah. Cool. Yeah, so definitely something you can do. Like, I haven't delved deep into it myself, but within the clusters configuration block, you can like do like weights, and you can also do things like location-based things. Like if you can actually, like say you're on AWS as an example, any cloud really, they often have a concept of availability zones, failure zones, whatever you want to call them. You can say, you can have like policy based on, if I'm in this locality, I want to preference this endpoint. So yeah, like it's entirely, and in terms of like managing, say, we're going to do 10% weighting, 20% weighting, basically from a control plane perspective, all that is like wherever you store your current intent, you just kind of update that value. It could be in like Terraform, it could be like just a YAML file on S3, who knows, and just update that, and then eventually the control plane will pick it up and just sort of gracefully transition that, update that value. Did anyone have any trouble with the labs or miss anything that they wanted me to chat about? Nope. Okay. Let me see.
So if you're using Envoy, say the ingress,
Yes.
you could, use Lua, or maybe there's something that already exists to say paint everything with a unique open telemetry ID.
Oh, yeah. So absolutely. Like built in, they have like tracing headers that you can enable, all that sort of thing. Like if I assume that's what you're going for, is like I want to identify this particular request across logs, across metrics. Yep. Yeah, absolutely. If there's something earlier in your stack, like say a CloudFront or a Cloudflare, you can configure it instead of like Envoy saying, I'm going to inject the ID. You can like, you know, like say, I'm just subsume this one, all that sort of thing. So you can have that truly full stack sort of flow through in terms of telemetry. In terms of monitoring, and this is not something that I touched on in this talk, but I probably should have, fully Prometheus compatible monitoring within our what I've been working on over the last basically year is what we call network functions orchestration clusters. And that's basically Kubernetes clusters that are tuned towards running data plane services. So rather than like running your terminal workloads and bin packing them onto nodes and all that sort of thing, we actually we de-bin pack, and we basically just run one envoy per node. Along with all the support services, daemon sets, that sort of thing. And like just the Prometheus compatible metrics, it's basically just like flicking on a light to get them all monitored, which was absolutely fantastic. Yeah. And that came with like the full, like both, like in the early stages, we were just like, we're just going to run Prometheus within our own cluster and have Grafana and all that sort of as part of the stack. But later on, it was like, we run Mimir for, I guess, our platform metrics, and the integration was basically just updating a few labels and some configurations, all that sort of thing. So it kind of, it just works, was kind of cool. One thing with regards to Envoy that we've actually encountered recently that that it's a problem we've kind of solved by just throwing compute at the nodes. But with routes and with a lot of a certain other, I guess you could say, rule evaluating filters, the one that sort of triggered, that we've noticed is the RBAC filter, which basically just applies rules. And funny enough, there's RBAC. You don't, like, while you're writing this configuration, you kind of expect it to be, it's not like writing code, but you still need to be aware of computer science fundamentals, because the route evaluation is linear. And if you have thousands and thousands of routes or thousands and thousands of RBAC rules, which we currently do, it takes, and like those are running, say, regex comparisons, matching on regex. You can actually, like, Envoy can get very CPU hungry very quickly. It's still very fast, and it doesn't like drop request or anything, thankfully, but it's, yeah. And what they're currently working on, it's still in the experimental phases, is I guess what's known as a unified matcher API, where you can, and this, so scoped routes was sort of their initial solution to the problem, but it only worked for routes. Basically, you could, scoped routes allow you to say, oh, for this request, based on some, you know, some data, like say maybe a header or something like that, I only want you to look at this particular subset of a route table. But I think what they're probably going to lean towards more is what's known as I said, the unified matcher API, where you can like define, you know, matching, like say different levels of matching, and like shard it based on, say, a hash map lookup or something like that. So you can say, oh, I'm going to match against, okay, things that start with this name, go to this route table, things that go to this name, look at this route table. And then it's still obviously linear within that bucket, but you've just saved yourself, you know, checking every single one for a match, rather than, you know, instead of just doing like a hash map lookup, which is super great. Yeah. From the ingress case, so the defaults within Envoy are, I guess, what you could say, geared towards the service meshy sort of world. They highly recommend, and they've got a guide in their docs about tuning Envoy for ingress use cases. Generally, that's like basically just being more conservative, and you generally trust clients within your own network, And so you can be more generous with buffers or waiting for connections, that sort of thing. Whereas if you're dealing with untrusted clients on the internet, you want to be more aggressive. Aggressively phasing out. And beyond that, you also need to not only tune Envoy, but you often need to tune the operating system itself. Particularly in a Kubernetes context, because again, Kubernetes very much tuned towards that bin packing, microservices, all that sort of thing. And therefore it sets very conservative, and for most use cases, very realistic limits for like file opens and all that sort of thing. But with Linux, with Envoy rather, like if you've got an ingress proxy, you could have thousands and thousands of open TCP connections. And those, like as I said before, everything in Linux is a file, so are those. And if you can actually exhaust, there's many things you can actually exhaust within the kernel. So there's like file opens, and then there's also things like net filter, bucketing, contract limits, all that sort of thing. It's very, like you could have to be very careful. And it's often these, when you hit these limits, it's not like, something will tell you, because it's like an operating system limit that you don't monitor. Did you have a question?
Yeah. Did you ever use Contour?
I've not used Contour, but it's again one of those similar to Istio, very much a control planey sort of thing. So it's same technology, to my understanding. Did you have a specific question about it?
No, I mean it works as a configuration layer for Envoy for
Yeah.
Kubernetes support. Like, just curious with
Yeah.
Kubernetes setups if you've ever tried.
Yeah, it's super awesome. That's like there's Trafic, I believe, and there's, as I said, Istio before. There's also now Envoy Gateway, which actually comes from the owners of Envoy. They all basically do exactly what that little tin can app that I showed earlier. There's no special sauce. It's literally just a templating engine at the end of the day. What we use, so basically what I talked about, the clusters, the tuned clusters, our first use of them was basically doing egress proxying. And that's why I showed earlier, like that capability to do dynamic forward proxying. And basically we want to say, you're this workload, and there you can access these endpoints external to Canva. And basically, we use the RBAC filter, which I talked about earlier, and all that to achieve that. And because, so like Contour, Istio, all those guys, they're very much, they target, and rightfully so, the 90% case. For us, we had a look at the available control plane options, and none of them really had, I guess, what you would call first-class support for like treating Envoy as like a forwarding egress proxy, and so we ended up writing our own. And that's all gRPC and based in Golang. I'm terrible at writing Golang, but I somehow managed it. And that's all powered by Kubernetes, CRDs, and all that sort of thing. So we're basically, currently we're just managing them through our own clusters using Argo CD, basically syncing them from our own repositories. Our long-term plan, and they're just getting started with this with one of the other engineers in my absence, is we've got like what we call an internal PAS, I guess, and basically you want to have like custom. Well, you don't want to own the policy anymore. We don't want to be responsible for updating. Like it's the dream in every networking team to like not have to manage firewalls, not have to manage proxies, rule sets. Basically, we want customers to be able to say, okay, these are the service identifiers that I manage. These are the things I want them to be able to access as part of their regular application definition, and have that pushed onto our PAS clusters, and then maybe do some validation checks, whatever, and then push through onto our network clusters, from which we actually do the data plane forwarding and all that sort of stuff. So that's That's the grand plan, at least. And we're also probably looking at ingress, and there's a lot more work that's been done in that area, so we're hoping to leverage something like Envoy Gateway or Contour or whatever. Our main, I guess, concern is that once you choose, I guess, an off-the-shelf solution, I've seen at least, you sort of lose control. Very often these things, I guess, operate under assumption that every, say, service or potentially every team or often they will have their own instances of Envoy. And like when you say bring up a service, that brings up a new ingress instance of Envoy, or indeed with Nginx. Whereas what we want to do is have a long-running multi-tenant Envoy, which is not at least to my understanding, not a well-served niche, because and also once you start doing multi-tenancy, like a multi-tenant edge, you have to not only make the feature set available to the customers who are consuming it, you need to decide which features they are not supposed to have access to. Like you have to do a bit of curation there as well, and control and decide what is appropriate and what is not. And the existing solutions, at least to my understanding, don't have that. Or you would have to have some layer of Kubernetes RBAC on top to make sure that this person can't set these values or whatever. So we're investigating that. What might happen is we create sort of, I guess, a shell version of the gateway API that customers can configure through their application definition, and then use that as a firewall, and transform those documents into Envoy Gateway or Contour-based configuration that then run on our clusters. That's one thing that's doing around in my head there. And to an extreme counterpoint, XDS, it doesn't always have to be XDS. At Atlassian, their first generation service mesh was basically, there was no XDS. They'd probably shoot me for telling you this little secret, but I will anyway. It was just a Ginger templated YAML file, classic solution, right? And it worked because the only time within their microservice model, at the time at least, that configuration changed was at deploy time. And you didn't want the sidecar to its configuration to mutate except when someone pushed a config update. So all they did was just generate a config file every time that someone did a deployment, and in prod, there was a forced deployment every week or something like that. But that's an entirely valid approach as well. Don't discount the place of the classic, Ginger template when it comes to Envoy and configuring it. Often there's going to be a hybrid approach. You will template your bootstrap configuration and then have some init container or something along those lines, an init script, render that, then have it connect to an XDS. That's a perfectly appropriate way to go about it. Yeah. Any other questions? Yeah, 10 minutes. Let me see if I can find my friends. Where are you? Ben? So you can see the massive drop in P99 when they transitioned from using TCP sockets to using Unix sockets for the connection to sidecars. So it's a very real gain that you get there, and I suspect it's because, yeah, you don't, in order to do concurrent, conversations for the sidecars, like you can do so many, within a gRPC stream, you can have a few concurrent conversations, but eventually you have to start spawning like parallel connections, and eventually that, like all of those, spinning up those TCP connections, even though it's on localhost, still has an overhead. Whereas once they brought it down and started using the Unix sockets, it was a marked improvement, which was apparently quite shocking to them. He's one of the lead engineers over at Atlassian, and he was skeptical. But yeah. So yeah, that's Envoy 101. I will be here if anyone wants to just come up and have a chat to me, or you're, I guess, free to go if you so desire. Also, thank you for listening. It was great. You were a great audience.